This watermelon is about to make history. Or, it's about to make a spectacular mess. But here's the cool part. That watermelon didn't just fall. It obeyed a set of universal rules that govern literally everything. From rocket launching into space to you tripping over your dog and face planting on the floor. These are Newton's laws of motion. And without them, well, you might be floating off the planet right now. Newton's first law, the lazy law. This slice of pizza right here is not moving. It's sitting there, perfectly still, on the plate. And unless I pick it up or gravity decides to take over, it's just going to sit there. Forever? Why? Because of Newton's first law of motion, also known as the Law of Inertia. Let's break it down. An object at rest stays at rest, and an object in motion stays in motion, unless acted on by an external force. In simpler terms, everything is lazy. Once something starts doing nothing, it wants to keep doing nothing. And once it starts moving, it wants to keep moving. Forever. Unless something comes along to ruin the fun. Friction, gravity, your dog stealing your pizza. Part 1. Couch potatoes and magicians. Let's put this law into perspective with something we can all relate to. Lying on the couch. Imagine this. You're sprawled out, perfectly still, binge-watching Netflix with a pizza slice in a hand. Life's good, you're relaxed, at rest, and unless someone shoves you, yells fire, or your pizza mysteriously disappears, you're staying there. Forever. You are now a Newtonian object, an object at rest staying at rest. Congratulations! But inertia isn't just for lazy humans. It's for everything. Ever seen a magician yank a tablecloth out from under a set of dishes? It looks like magic, right? Nope, it's physics. The dishes stay put because they don't want to move. They resist change. The force of the magician pulling the tablecloth is fast enough that friction doesn't have time to pull the plates along. So they sit there, unbothered, demonstrating inertia like a boss. Part 2. Inertia in space. The universe lazy zone. Now let's level this up. Picture yourself in outer space. No gravity, no air, no friction. It's just you, a basketball, and nothingness. You give the basketball a push, and what happens? Does it slow down and stop? Nope, it just keeps floating. Forever. Why? Because there's nothing to stop it. No friction to slow it down. No air resistance to get in its way. It's like the universe's version of a lazy river. Except instead of water, it's just empty space. Inertia is the reason why everything in space behaves so weirdly to us earthlings. We're used to friction. Cars stop when you hit the brakes. Your bike slows down when you stop pedaling. And your pizza, well, it stays put unless someone eats it. But in space, things stay in motion forever, which is cool and a little freaky. Imagine tossing your phone out the window in zero gravity. Don't actually do this. That phone would just keep going for eternity. It wouldn't stop until something crashed into it. That's why astronauts look like they're floating. They're not. They're actually moving at the same speed as their spaceship. Inertia just makes them look chill, when really they're zooming through space at thousands of miles an hour. Lazy but fast. Part 3. You and inertia. The car example. But let's bring it back to Earth. Because Newton's first law doesn't just apply to magicians and astronauts. It applies to you. You've experienced this before. Ever been in a car when the driver slams on the brakes? You lurch forward, right? It's not because you're clumsy. It's because you were in motion. And inertia wants you to stay that way, even when the car stops. Here's the science. Your body is moving at the same speed as the car. When the brakes hit, the car stops, but your body keeps going. That's inertia. Seatbelts exist for this very reason, to keep you from becoming a human missile when inertia does its thing. Part 4. Everyday inertia, it's everywhere. Inertia is sneaky. It's happening all the time, everywhere, even when you don't notice. Ever spill coffee when your bus starts moving? That's inertia. Your coffee wanted to stay still. Ever struggle to move a giant couch? That couch doesn't want to move. It's resisting you. Like the stubborn object it is. And when you finally get the couch moving, it doesn't want to stop. You're now chasing a runaway sofa across the room. Inertia explains why stopping a soccer ball is easier than stopping a bowling ball. The bowling ball has more mass, so it has more inertia. And more inertia means it resists change even harder. That's why you'd rather have a tennis ball flying at your face than a bowling ball. Part 5. Historical inertia. Why we care about Newton. Here's a fun fact. Sir Isaac Newton figured this out in the 1600s. Before that, people believed objects naturally came to a stop because they wanted to. Turns out, they don't stop because they're tired. They stop because something stops them. Newton changed how we understand the world. He realized the natural state of objects isn't stopping, but continuing. If you take away friction, resistance, and other forces, things just keep going. Forever. Newton turned the universe from a magical place into a predictable, logical one. And all because he sat under a tree and probably got bonked by an apple. Final thought. You're a living example. Newton's second law, the power law. Here's the coolest part. You're made of atoms and molecules that follow this law. Every time you move, stop, or sit still, Newton's first law is at work. Inertia explains why your body fights to get out of bed in the morning, why it's so hard to push a stalled car, and why you feel you're flying forward when the roller coaster stops. It's not you, it's physics. So next time someone calls you lazy for not moving, just say, it's not laziness, it's inertia. I'm obeying Newton's laws. But what happens when you do decide to move? That's where Newton's second law takes over. This is a bowling ball, and this is a tennis ball. I'm going to push both of them with the exact same force. Ready? Boom. The tennis ball takes off like it's late for a date, and the bowling ball, it barely rolls a couple of feet. Why? Because of Newton's second law of motion, the law that explains why moving heavy stuff feels like you're arm wrestling the universe. What is Newton's second law? Let's start with the basics. Newton's second law says, force equals mass times acceleration. Sounds like something that belongs on a physics exam, but I promise it's simpler than it looks. Here's the cheat sheet. Force, that's a push or pull you apply to something, like when you kick a soccer ball and pull your little cousin on a sled. Mass, that's how heavy the object is. Think bowling ball versus tennis ball. Acceleration, that's how quickly something speeds up or slows down. When you put it all together, if you want something to accelerate faster, go further, go faster, you need to apply more force. And the heavier it is, the more force you need. The universe doesn't give you free wins. Everyday life, the office chair versus the couch. Let's test this law out in your living room. You give an office chair a tiny push, and it zips across the floor like it's got somewhere to be. Now swap that office chair to your big, bulky couch. You lean into it, you grunt, you make weird faces as you push with all your might, and it moves a whopping 6 inches. Why? Because the couch has way more mass. More mass, more resistance to acceleration. Newton's math makes it clear. You've got to push harder. Here's where it gets fun. Think about shopping carts. An empty shopping cart? You can push it with one hand and watch it glide like butter. A shopping cart filled with 12 watermelons, a box of rocks, and your cousin for good measure? Good luck. Same push, way less acceleration. The rocket example. Force gets you to space. Now let's level this up. Literally. Newton's second law doesn't just explain couches and shopping carts. It explains how we launch rockets into space. Here's the deal. Rockets are heavy, like thousands of kilograms of fuel, engines, and space tech. And to escape Earth's gravity, they need to accelerate at insane speeds. But how do you get something that big to go that fast? Force. Lots of it. The engines create a massive push downward, and Newton's second law does its thing. The force accelerates the rocket upward. More force equals more acceleration, and before you know it, the rocket is leaving the atmosphere at 25,000 miles per hour. That's right, space is basically a giant physics flex. Testing it yourself. Heavy ball versus light ball. Here's where you come in. If you want to see Newton's second law in action, grab 2 balls, one light like a tennis ball and one heavy like a bowling ball, or something close. Push them both with the exact same force. What happens? The tennis ball takes off like it's auditioning for the Olympics. The bowling ball barely moves. Why? Because the bowling ball has more mass. And Newton's second law says the same push won't create the same acceleration. Heavy things just don't move easily. That's why Sisyphus is still pushing that boulder uphill. Newton was right. Why this law is everywhere. The cool thing about Newton's second law, it's everywhere. Every time you move something, kick something, or stop something, you're living it. When you throw a baseball, it accelerates faster than a shot put because it's lighter. When a car engine applies force, a smaller car accelerates faster than a big, heavy truck. That's why sports cars zoom past trucks like it's a Fast and Furious movie. And when you try to stop a moving shopping cart full of groceries, you feel the force pushing back on you. The heavier the cart, the harder it pushes. Newton's math wins again. You versus Newton's math. But here's the kicker. Newton's second law explains why life feels unfair sometimes. Ever tried to push a stalled car? You're not weak. It's physics. The car has so much mass that it resists your force. Or when you carry a full backpack uphill and it feels like gravity itself is out to get you? That's mass and force playing tug of war. So next time someone tells you to just push harder, feel free to explain Newton's second law. Or better yet, tell them to push it instead. You'll look smart and save your energy. Final thought. Newton made the universe predictable. Newton's second law might sound like a simple equation, but it's powerful. It explains why rockets blast into space, why couches are impossible to move, and why you feel like a superhero when you send a soccer ball flying with one perfect kick. Force, mass, acceleration. 3 little words that shape everything you do. So the next time you struggle to move something heavy, don't blame yourself. Blame Newton. And maybe grab a friend for backup.